Why are black holes important? Black holes are unusual and interesting cosmic objects. Light can't escape their gravitational pull since they're so dense. Milky Way may contain 100 million black holes, but finding them is tough. At the center of the Milky Way is Sagittarius A star. NASA says the massive behemoth is 26,000 light-years from Earth and 4 million times the Sun's mass. EHT captured the first photograph of a black hole in 2019. The snapshot of the black hole 55 million light-years from Earth excited astronomers worldwide. Einstein's general theory of relativity predicted black holes in 1916. John Wheeler invented black hole in 1967. After decades as theoretical objects. Cygnus X1 in the constellation Cygnus, the Swan, was the first black hole detected. NASA's sounding rocket spotted X-rays from the black hole in 1964. Opens in new tab. In 1971, scientists found the X-rays came from a blue star circling a dark object. The discovered X-rays may have been caused by stellar material being gobbled up by a black hole. 1 in 1,000 stars is big enough to create a black hole, according to STSCI. Our galaxy must have 100 million black holes as it has 100 billion stars. NASA thinks there might be 10 million to a billion star black holes in the Milky Way. The unicorn is 1,500 light-years distant and is Earth's nearest black hole. Double meaning moniker. The black hole candidate's modest mass, around 3 times that of the Sun, makes it almost unique. The EHT partnership published the first black hole picture in 2019. The EHT spotted the black hole in galaxy M87 while analyzing the event horizon, the area from which nothing can escape. The picture shows photon loss, particles of light. Now that scientists know what a black hole looks like, additional study is possible. In 2021, researchers presented a polarized image of M87's black hole. Polarized light has a different direction and brightness than unpolarized light, therefore the new picture is more detailed. The graphic shows that the black hole's ring is magnetized by its polarization. Black holes have 3 layers: outer, inner, and singularity. Beyond a black hole's event horizon, light cannot escape. A particle can't exit after crossing the event horizon. Event horizon gravity is constant. The singularity is the place in spacetime where a black hole's mass is concentrated. Black holes aren't visible like stars and other cosmic things. Astronomers must detect the radiation black holes release as dust and gas are sucked in. In the heart of a galaxy, supermassive black holes may be obscured by dust and gas, blocking their emissions. Matter attracted into a black hole sometimes ricochets off the event horizon and is thrown outward. Bright, near-relativistic jets are formed. The black hole can't be seen, but these strong jets can. The EHT's 2019 picture of M87's black hole required 2 years of investigation after the photographs were obtained. The global collaboration of telescopes creates too much data to transport through the internet. Researchers want to photograph more black holes and develop a database of them. The next target is presumably Sagittarius A*, our galaxy's black hole. Magnetic fields may be suffocating Sagittarius activities, *S, according to a 2019 research. Another research that year found that Sagittarius A* had a cold gas halo, giving unique insight into a black hole's surroundings. Astronomers have identified stellar, supermassive, and intermediate black holes. Stellar black holes, small but deadly. A star may collapse when it runs out of fuel. Smaller stars, up to 3 times the Sun's mass, will form neutron stars or white dwarfs. A bigger star that collapses forms a stellar black hole. Small, compact black holes emerge when stars collapse. One item packs 3 times the Sun's mass into a city's circumference. This causes insane gravitational force on nearby objects. Black holes in galaxies eat dust and gas to develop. Supermassive black holes, the birth of giants. Supermassive black holes rule the cosmos. Black holes are millions or billions of times as big as the Sun but have the same diameter. Every galaxy, including the Milky Way, is assumed to have a black hole in its heart. Large black holes are a mystery to scientists. Once created, these giants collect dust and gas from galaxy centers to become even larger. Hundreds or thousands of small black holes may combine to form supermassive black holes. Large gas clouds collapsing and accreting mass might be to blame. A stellar cluster collapsing is a third possibility. Fourth, dark matter clusters might form supermassive black holes. Dark matter's gravitational impact on other things can be measured, but we don't know what it's made of because it doesn't radiate light. Intermediate black holes. Mid-size or intermediate black holes, IMBHs, may exist, contrary to previous beliefs. When cluster stars collide, these bodies can develop. Several IMBHs growing in the same location might eventually merge to generate a supermassive black hole. In 2014, scientists spotted a black hole in a spiral galaxy's arm. Using an old gamma-ray burst, scientists found one in 2021. Astronomers have been seeking for medium-sized black holes, said Tim Roberts of Durham University in the UK, opens a new tab. IMBHs are like a long-lost relative who doesn't want to be discovered. 2018 research suggests IMBHs in dwarf galaxies or very small galaxies. X-ray activity in 10 galaxies, 5 of which were unknown to science, suggests the presence of 36,000 to 316,000 solar mass black holes. Sloan Digital Sky Survey studies 1 million galaxies and can detect light from black holes consuming surrounding material. Binary black holes, double trouble. LIGO discovered gravitational waves from merging black holes in 2015. We've confirmed the presence of stellar mass black holes greater than 20 solar masses, stated LIGO spokesperson David Shoemaker, opens a new tab. LIGO's measurements reveal a black hole's spin direction. Two black holes spiraling around each other might spin in opposing directions. Binary black hole formation is disputed. The first proposes that binary black holes arise from two stars that were born and perished together. The partner stars' spin orientations would have matched the two black holes left behind. Second, black holes in a star cluster sync to the center and team together. LIGO's scientific collaboration says these partners have unpredictable spin orientations. LIGO's findings of black holes with varied spin orientations support this idea. Why are they important? Black holes explain the erratic motions of some stars and help astronomers make sense of our galaxy. Einstein's theory of general relativity asserts that matter warps time and space, causing gravity. Black holes are very dense conglomerations of matter, thus their gravity. Then, they physically tested Einstein's hypothesis. Looking at a black hole singularity is challenging. Science can't agree on what will happen because of the huge forces involved. Einstein's general relativity claims matter's information is annihilated in a black hole, but quantum mechanics indicates that's not true. Astrophysicists and mathematicians use black holes to reconcile two ideas. Black holes challenge fundamental ideas that explain how the world works, from general relativity to quantum physics and string theory. Can we see them? Black holes have so strong gravitational force that not even light can escape, making them invisible. Instead of traditional telescopes, scientists utilize radio telescopes and gravitational wave detectors. Albert Einstein proposed in 1915 that things traveling through space form waves in spacetime, like ripples on a pond. In 2015, physicists at the Laser Interferometer Gravitational Wave Observatory first observed gravitational waves, LIGO. 1.3 billion years ago, two black holes collided. Black holes are identified by the influence they have on their surroundings. They suck in gas, dust, and stars, which become superheated and emit radiation that may be seen as a thermal picture. In April 2019, the Event Horizon Telescope took a photograph of a black hole and its shadow in the galaxy Messier 87, part of the Virgo galaxy cluster. The picture depicts a brilliant ring surrounding a black hole 55 million light-years from Earth. This halo is the heat given off by hot gas spinning about the event horizon as it's pushed in. What would happen if you fell into one? What if you fell into a black hole? Whatever kind of black hole you select, the prognosis isn't good. If you jumped into a stellar mass black hole, your body would spaghettify. No, really, it is. The black hole's gravity would squeeze and stretch you. Spaghetti. Let's say you choose a gigantic black hole to make your huge leap for humanity and science. Sagittarius A* is a supermassive black hole at the center of the Milky Way, 44 million kilometers wide and holding 4.31 million solar masses. Bruce Ballack and Robert L. Brown discovered it in 1974 but didn't name it until 1982. After crossing the event horizon, you'd enter Sagittarius A*. From inside, you could look out, but no one could see you since light would reflect off of you. Although the gravitational pull is stronger than smaller black holes, the tidal force is less, thus you won't turn into spaghetti. But you couldn't escape. Or could you? Your hope is white holes. If a black hole swallows things, a white hole spits them out, and the two are connected by a wormhole. If you wait long enough, the black hole may turn white. This procedure takes billions of years, but don't worry. Why? Due to the strong gravitational forces, you'd be done in milliseconds. This is a theory for now. Consider the 2014 tidal disruption detected by 3 NASA telescopes. A star came too close to a 290 million light-year away black hole in a galaxy's center. As it was pulled towards the singularity, it was deformed, stretched, and torn, and its remnants were ejected as a cosmic belch 6. Thank you for being with us. Don't forget to subscribe.